Okay, let's talk about subtraction of vectors. So you will know how to subtract vectors. You will be able to recognize a vector subtraction situation, which is by far and away the hardest of those two things.
Once you get this done, that's it. Everything's easy from now on.
No.
Easier.
No.
It gets harder.
Yeah. It's physics, man. No one ever took physics because they heard it was an easy mark.
True.
You know? It's that'll boost. That's a GPA booster. Let's take physics.
Yeah. That's a count. That's what makes
Okay. So you've got a sheet there. Follow along, please. So you know where you are. So what do you think subtraction of vectors means? And I'm going to give you a hint. Addition of vectors means placing them tip to tail.
It's the other way, tail tip.
Tail to tip, okay? Lots of, I guess, could be tail to tail too.
Yeah.
Few different ways. So let me sort of explain it using something that you already know, which is scalar subtraction. You're all familiar with subtraction. You learned in grade 2 maybe. 7 minus 4, stuff like that, right? So subtraction of scalar numbers can be rewritten as addition. You learn this usually about grade 6 or 7 when you first start talking about integers. Johnny, you guys stay with me. Okay? When you first start talking about integers, you learn this kind of stuff. Stuff like 10 minus 6 is the same as up here. See, this is the explaining part. Okay, this is where you learn it. And then later you practice it. So 10 minus 6 can be rewritten as 10 plus minus 6. Would you agree that those are the same thing?
Absolutely.
10 minus 6 is the same as 10 plus negative 6. And would you also agree that negative 6, we would call it the negative of plus 6?
Yeah.
Okay, so we've taken what we call scalar subtraction and we've rewritten it as addition. We're adding the negative or adding the opposite. Now, do you think this sort of concept or this idea can be used for vectors?
I'm going to guess so.
Yeah, because why else would you be talking to them about that, man? Exactly. Okay, so we're going to do the same thing. Do I not have something else here? But it feels like I should have one more thing. No, I guess not. Okay. So, what then is the negative of a vector? What does it mean to take the negative or what is the opposite of a vector? Any ideas? Do you have it?
Backwards.
Backwards. The negative of a vector is simply a vector having the same magnitude, which means the same length, the same size, the same number part, but exactly the opposite direction. I see a bunch of people writing stuff down, and that tells me that you should be doing that, and I see a few people who are not doing that. So that tells me that they're not following along the sheet because they don't know that they need to write it down. Should I? Oh, well, whatever you want. The negative of a vector is a vector having the same magnitude, but exactly the opposite direction. Now I'm going to do a little bit more teaching here, and then did you notice how I set the clickers up? So in about, maybe 90 seconds or less, you're going to have to show me that you get what I'm saying. So pay attention. Don't wait till then and say, well, you never showed me. I don't know. I'm showing you right now. Okay, so for example, if that's vector A to the right, well, it would be vector negative A. Going the other way, to the left. Pretty straightforward, right?
Yeah, right and left.
Yeah.
It's almost as straight as I want.
It's almost a straight line. If vector B is up and to the right, down and to the left. Would you say those lines are parallel, Brett? Parallel, like
Yes.
yeah, opposite directional. Yeah, parallel.
Yeah, parallel.
Yeah, exactly opposite direction, right? If I take this one, can I do this? Yes, I can. Like exactly the same, right? Just one. You could even say a 180-degree turn, right? When you pull a 180, what does that mean? Going backwards. Going back the way you came. Okay, I'm going to give you a little harder question. If the original one was a bearing of 10, 0, 1, 0, if C is at 10, negative C would be?
190.
190. Right? There's 0. There's 90. So there's 10. So exactly the opposite would be, I'll do it different color. Oh, same color.
Nice different color.
I woke up this morning and I was colorblind. It totally came out of the purple.
Wow, just like Johnny.
Totally out of the purple, right, Johnny? Get it? Get it?
I do.
It's not blue.
It's not blue.
I really don't care.
Come on, he's trying to
Someone explain it to him later.
Because out of the blue,
Is the
like
expression.
colorblind.
Oh.
Okay, so if the red one here was 10, right, then that angle would be 190. How did I get 190? I added 180. Right? I added 180 to 10, and I got 190 without a calculator. Brett says so if 300 was D, negative D would be 120, right? Why did he subtract 180? Why did he not add 180?
Is that good enough?
Because it would go past 360. We've already, we're past 180, right? So instead of adding 180, you're just going to subtract it.
Does that give me the same answer?
Yeah. Well, you'd go to 360, but then you'd have to subtract 360, right? You could add it, but then you'd have to subtract 360. Okay. One more. I want you to stop and think about this one a bit. I'll pause for a second. Okay, what do you think? So south 15 east. Well, I guess you could draw a picture. South is down, 15 east would be like that, right? With the 15 in there. So 180 would be Did you say left?
No, west. When's 15 left?
Leo's got it. North, 15 west.
Okay.
It's really pretty simple, isn't it? What did you do?
You did the opposite side.
You just take the directions. It's kind of like being a teenager. Whatever your mom says, you do the opposite.
Right.
Just turn around and walk away.
Okay, well,
Walk away.
don't let mom hear this video. South 15 east, you change south into north, you change east into west, and it really couldn't be any harder, right? Okay, now go get a clicker. Okay, so here's your first question. It's a bit of a trick. What is the negative of 10 meters per second east?
Do it.
A, B, C, or D? I do this trick question on purpose. It's not negative 10 west, it's just 10 west.
Well, because west and east are opposite.
Oh! Can I do this one? Yes, I can. So if vector x is 25 kilometers an hour at north 30 east, which one is going to be negative x? Keep it to yourself. So we're going to get it all right?
Oh, one person.
How do you get it? How do you do it? You change north to south and you take east and change it to west.
Boom, you're done.
Boom chicken soup, you're done.
You said it out loud.
Okay. To subtract vectors. Now, what did we do? I showed you how to find the opposite vector. So when we did scalar numbers, we added the opposite number. So how are we going to do it with vectors? Here's the star. Here's the big idea for the day. Here's the thing you got to know. To subtract vectors, find the inverse of the vector to be subtracted, find the opposite, and simply add it like I taught you last week. That's it.
Wow.
Flip the one to be subtracted and just go ahead and do adding. Flip the one that you're subtracting and go ahead and add just like I showed you last week.
Okay, I get it. Oh, wait.
How do you know which one to subtract? That's a good question. Well, if it says A minus B,
It's probably the V.
it's the B. You flip and add. That's it. If you want to condense it down, flip and add. Okay? So,
you still add it the way after you flip it? Or
yeah.
before you flip it?
No, you add after you flip. Flip and add. In that order. Okay, so there's A. So if this is A and this is B, why do I flip B? Because it says minus B. Right? So I'm just going to take this one and I'm going to,
Wait, so what if they're like,
that's minus B.
they're like touching each other?
They're not touching each other until I do the addition, right? So now I'm going to take A
It never will be though?
and I'm going to add minus B.
Ooh.
Right? And there's my answer.
Oh.
A minus B. Flip the B and add it.
Simple.
If it's a right triangle, use Pythagoras. If it's not, ruler and a protractor. When you say it that way, it's not that hard. But for some reason, kids always have trouble with it. It really is.
You also said it's the hardest thing.
I don't know. Yeah, you're right. But
90 degrees, right?
I don't know why people find it hard. Because it's literally flip and add.
I mean 90 degrees.
180.
No, but like, it's a right triangle.
You wrote stuff there? Okay.
That's why I don't write stuff.
True.
That last page was pretty important.
Like the free throws, if you imagine doing it, and if you do it, you get the same result.
Oh my god. Here we go.
All right. So 10 meters north and B is 50 meters east. What is A minus B? So you take, the first thing you got to do is figure out what the B is, right? Well, we're subtracting B. Johnny, are you watching? So minus B is going to be 15 meters west. And then you just add like we did last week. So I'm going north. Yeah, 50 meters east, 50 meters west. That's the opposite. Right? And I would suggest you label it minus B so that I can see it. Right? And there's your, now we call it the result still. Okay, and then it's just, that's 10, that's 15. So you're really just, now, some of you wise ones out there will realize that whether I flip B or not, it's still going to be 15 squared plus 10 squared, right? So the only thing that really changes is the direction, the angle. Exactly. Right? Is it any wonder I leave subtraction to after addition? Like, I mean, that's the way to do it, right? Yeah.
Do you still need a protractor to find the angle?
No, we're going to use tangent. Oh, I hate this calculator. $18? Did you get 18?
Yep.
So that's going to be 18 meters. There's your angle. Remember, how do you know what angle to do it at? The one where you start, right? Where you started drawing, there you are. And the reference. So that's going to be theta is equal to second function tan, opposite, which is 15, adjacent, which is 10. Really? So that's going to be 56. But what are the directions that we're going to use?
North.
From here, from the little blue guy, we're going north. And then we go 56 to the west. So north, 56 west. That's it.
That's the whole.
That's it. That's all there is to it.
Well, I guess so.
I guess so.
Well,
Think there's a clicker coming?
Could be.
You're catching on, Jeff. So we're looking for A minus B. A is 5 meters per second north and B is 4 meters per second west. So those are your three choices. Which one is the vector subtraction? No, you didn't. It's not possible.
All of the above.
Yeah, all of the above.
Oh, yeah. One of those guys.
5 meters per second north. B is west, so minus B is going to be
East.
4 east. So we're going north and we're going east. North and east is going to be
Press someone in.
C.
Press someone in.
Which one do you flip? The one you're subtracting. Okay. This is not a clicker. This is the hard part. How do I know to subtract, Mr. Ben? Well, the easiest way is because it says subtract. It says subtract, like A minus B, right? So here's A. Oh, that's not minus B, is it?
Nope, it ain't.
Sure ain't, is it? What happens when I click here?
The opposite.
Nope.
Still wrong.
Still wrong.
Should we flip the
Yeah, fix that.
arrowhead on the other side?
What the? Oh, it's like, but I will point out,
Oh, the result is right.
yeah, so really, if you want, right, there's B, that negative B is really that way, right? Yeah, you're right. It should be that way, right? But did you notice that they were tip to tip? Right, so tip to tip is kind of the same thing, but I prefer the flip round. It's better. Okay? So how do you know when to subtract? It says subtract. Like if you mess that up, there's not much I can do for you. It says subtract. It's like where it says main, if you put 12 in there, can't help you. Okay, here's the hard one. Now I realize I'm giving you a lot of information. Maybe you're starting to, your focus is waning a little bit. Focus in here, okay? Mervin? It implies subtraction. So that means that it doesn't come right out and say it. It just sort of kind of is a hint. It implies subtraction because it asks for the wind or the plane speed or the current or the boat speed. So I'm just going to do this. I'm going to explain, as I always do. Right? So, if you're talking about planes and wind, right, would you agree that the resultant, the answer, the overall final result is the plane vector plus the wind vector?
Yeah.
Right? Like if you're flying along and the wind blows you this way, your resultant is because of your plane speed plus your wind speed. Addition. Okay, but what if I want you to find the wind or find the plane speed? Because normally, like if I want to fly to Brandon, which is pretty much straight south, that's 1 degree off, I think. Let's assume it's straight south. If you want to fly to Brandon straight south, but the wind is blowing towards Saskatchewan, which way should you aim your plane? Like towards Miquelon, Mercury, right?
Yeah.
That way, and the wind will kind of push you back, right? That means you're trying to find the Yeah, you're trying to find the plane speed, the plane velocity. You're trying to find the angle that you should aim at. That is a vector subtraction question. Why? Because if I isolate for P here, how do I get P all by itself? I take the W to the other side and I get, oh, not R minus P, R minus, R what W? Oh, it says subtract. How do you know it's subtraction? Because it now says subtraction. This isn't that hard. If I have to ask you for the wind speed, which happens from time to time, doesn't happen so much in real life, but in the land of physics it does. So if I'm solving for W, I'm going to take the P to the other side, and it's going to become?
Something like that.
Now, how do you do this again? R, let me put it in blue again. R, not minus, but plus minus W, right? R add minus wind. Take the wind speed and
Add it, flip it, add
flip it and add it. Here the wind is going to be R plus minus P. Flip the plane speed. Never change. Well, because it's out front, right? You're subtracting the other one. Okay, now the other more common situation is rivers and boats. I'm going to call them boats and currents, right? The river current. Got to be aware I got some non-English speakers in the room. Current, like which way the direction the water's going. Okay, so resultant is boat plus current, which means R is equal to B plus C. So if I'm solving for B, it's going to be R minus C, where C is the current, the direction that the river is going, which would be really R plus minus C. And you just flip it and add it.
What if the wind changes?
Oh, that's a really good question, yeah.
Any freak out.
Well, and a navigator, yeah, no. Yeah, just keep flying around. Oh, let's decide where we're supposed to go this direction, right? I mean, they set their course and they adjust it from time to time, right? If the wind changes, they have to reset. As long as they kind of get themselves to Winnipeg-ish, they can see the runway. Oh, I'm headed over there, right? Yeah. Yeah. They don't fly blindfolded. No, I'm going that way.
No.
I'm going that way.
The math tells me it's right.
Yeah, math tells me to go that way. I'm not going to look. The current is going to be R O minus B, or R plus minus B. It's really that easy. Now, it looks easy. Putting it to use can be a little challenging. I don't know why. Kids they just can't get it. So we got to practice. Just like it said, right? Let's do a practice one.
Oh, it tells you what to do.
Yep. In the first one, it gives you A and B. In the second one, it doesn't, right? Should I give you time to do both?
Yeah.
Let's try that.
How long?
I don't know. There's 2 practice questions on the back there. So I'm going to say like, I don't know, maybe 8 minutes? Something like that? 8 minutes should be enough time.
Which 2 are you getting at?
Yeah, they say practice there on the sheet. What's the number?
Oh, no.
Yeah?
Answer
Is that the number?
That's 36.
Yeah, that's too much. What's the number? 30.
36.4.
Okay, there's your answer, right? Is
Aw.
that right?
I did so much
Yeah.
more. Yeah.
So let's just go through this here. So what do we do? 35 north, we're subtracting B. So instead of 10 meters per second east, subtracting B is going to be 10 meters per second west. So 35 north, add minus B, that's 10. So you got R squared equals 10 squared plus 35 squared. How come I can do this? How come I can do Pythagoras? Because it's a right triangle. You get 36.4. Find the angle. Opposite is 10. Adjacent is 35. You get north 16 west.
I don't get it.
This bottom one's confusing.
Yeah?
Oh my god.
You want me to give you a little boost here?
Yeah.
Yeah.
Okay. A plane needs to end up with a resultant velocity of 100 kilometers an hour at east 30 north. So that is your R. A plane needs to end up with a resultant velocity of 100 kilometers an hour at east 30 north. The wind speed is 25 at north 15 west. What direction speed should the plane take? We are solving for the P, the vector P. Now, I recommend you write this. Start it with R equals P plus W. Yeah. Resultant is plane plus wind. Start with that, because then you can show me that you get this is vector subtraction, because I'm solving for the P, right? I'm solving for the p vector. So that's going to be, when I take that, isolate p all by itself, the w goes to the other side. What does it become, Zane? No, the w goes to the other side. That plus w goes to the other side and becomes r minus w. And now I've turned it into vector subtraction. When you do that, you're signaling to me, I understand this is vector subtraction. And then I can look at the rest of it and say, well, okay, they got a 2 out of 4 here. If you don't do that, then I don't know that you know it's vector subtraction. So what I'm trying to say is, put that. If you want me to understand what's going on in your brain. Okay, so now let's do it. 100 kilometers an hour at east 30 north. Now, it wouldn't hurt to have a little sketch, right? A little pre-work here. East 30 north. East 30 to the north is going to be like that, right? That's going to be my R. You know, the pirate's favorite letter? R. The wind is 25 at north, 15 west. Now, do I flip the wind?
Yeah.
How come? Because it says so right there, minus W. So instead of north, it's going to be south. And instead of west, it's going to be east. So from here, I'm going to go south, 15 east. South is down, 15 to the east is going to be like that. So this is going to be my R. And this is going to be my minus wind, right? Okay, so there's my little sketchy. Yeah, it's kind of sketchy. So now I'm going to do it for real. I'm going to draw a reference line. I'm going to have to come up with a scale too, aren't I, right? 1 centimeter equals, I got 100, I got 25, 10, okay. 10 kilometers per hour. I got to go east 30 north, east 30 north. So I need a protractor. Insert protractor. Oh.
That is not
From there, I'm going to go east 30 north. 30. Right there. Come on, get.
all right there.
Okay, how far? 100. So that means I got to go 10, right? Ruler. Oh, this is so much easier with paper. Always the wrong corner. Easy for you to say.
Take your time.
I'm not saying it's good.
Take your time.
Okay. I got to go all the way to 10.
We got a straight line.
It does. It's cool how it follows. It knows that I'm following a ruler. It's so cool. Okay, so that would be my R, right? That would be my R. Then I'm going to go the minus W. Then I'm going to go north 15 west, right?
Right, yes.
No, because it's minus. So I'm not going to go north 15 west. I'm going to go south 15 east. So do a reference line. South. We're going to go south. So put 0 at south. At the top right there, right? And I'm going to go 15 south, 15 east. Okay, so that's going to be there's south, 0, 10, 15 is going to be right there, right?
Yeah.
Right here, south 15 east. Get rid of the protractor. It's 25, so I'm going to go 2.5. Come on, you.
Oh, almost perfect.
That's because there's a little There's a little protractor that tells me the angle. And I'm going 25, so it's going to be? Yeah, I know. 2.5, right? I went a little bit too far, I think. And then my resultant is from? Actually, I'm going to do it this way. My resultant is, oh, it's not my resultant, is it? It's the plane, right? So from there, where I started to there. And then I just have to, now how do you find the answer? Here's the frowny face. Here's the thing that if you want to drive me crazy, and I know you do, how would you do that if you were intent on driving me crazy and making me mad? What would you do?
It's just a theory.
Take one and flip it. You would say, oh, that looks like a right triangle, Mr. Bennett. I'm going to use Pythagoras. Actually, it does kind of look like a right triangle, doesn't it?
What's wrong with that? It looks like a right
It does, looks like it, but that doesn't mean it is. I mean, I look like a nice, friendly guy. Was that you, Sierra?
You're a right triangle.
So how am I going to find it? You're going to have to actually measure, exactly. You're going to have to get your protractor, your ruler out, and you're going to have to actually measure. It looks to me to be about 9.8. 9.8 centimeters. 1 centimeter equals 10, so that's going to be 98 kilometers per hour. And how do I find the angle? Bring in the protractor. And again, where do you measure from? You got to measure from a reference line. Right? So that reference line is going to be east. So I'm going to bring it in there and I'm going to measure it from east. So that looks to be about 15, right? So that would be east 15 north. There's a lot of steps there. Right? There's a lot of things to sort of know. It's not hard, it's just a lot of steps. It takes what? Takes practice. Fortunately, I showed you the benefit of practice today, and I provided you with 4 of them with answers.
Right on.
Not just answers, but solutions.
Wow.
Should you do them? Yeah, you should.
No.
Hang on, let me turn that off before it goes all for the next hour, like I sometimes do.